Hi, and welcome to Allen High School's discussion of solutions at the 10th grade pre-AP or honors chemistry level. We're shifting our focus in the discussion by delving into what are considered electrolytes or electrolytic solutions. What is needed of our solute for a solution to be able to conduct electricity? So there's two criteria that we're going to focus in on. One, the substance has to be dissolved in water. So we're talking exclusively of aqueous solutions right now. And secondly, we need ions. And here's why we're going to need ions. These ions are going to give the solutions the ability to conduct electricity. And that's because mobile ions are going to provide this pathway for the movement of electrons. So mobile ions provide a pathway for the movement of electrons. And so that's what we need for a solution to be called an electrolyte. So we're going to start with our soluble ionics and look at how they're classified. If it is a soluble ionic, it dissolves and dissociates 100%. So we'd use that single arrow to indicate 100%. And because they dissociate 100%, we call them a strong electrolyte. If I forget, please remind me to set up the conductivity light bulbs to show you the difference between a strong electrolyte and a weak electrolyte. All right, strong acids and bases, you have to memorize those. And once you've done that, you will recognize them as strong electrolytes. Again, because they proceed 100% to form their products, which are dissociated ions. Now, let's contrast these solutions to some other possibilities. Weak acids and weak bases do dissociate, but they set up a reversible reaction and they dissociate less than, usually much less than 100%. So the few ions that are formed will provide a pathway, but it won't be a very strong pathway. It will be a weak pathway, so we're going to call them a weak electrolyte. They weakly conduct electricity. All right, again, contrasting those, if you have melted, just because it conducts electricity, that doesn't mean it's an electrolyte. So if it's a melted ionic compound, we learned this last semester, and metals, which you should know intuitively, whoops, I can't spell there, pen got away from me, metals conduct electricity. So they are conductors, but they're not considered to be electrolytes. All right, so just because it conducts doesn't mean it's an electrolyte. It has to be an aqueous solution of ions to be called an electrolyte. Now, if we have covalent substances, we may have the aqueous part. So if we have covalent molecules as our solute, such as sugar would be a prime example. Yeah, it dissolves, but it doesn't break into ions. So we have the aqueous portion of it, but we don't have the ion portion of it. So these are called non-electrolytes. So we have strong electrolytes, weak electrolytes, non-electrolytes. Now, if we have ionic compounds, there's one last class. You won't deal with these at all until we are in, well, maybe a little bit at the end of the year we do a couple. But by and large, we're not going to talk about this as much until you have that opportunity to take AP chemistry with me. If we have insoluble ionics, I'm going to be honest, they do dissolve a little bit. And in fact, this is not really correct. They dissolve a teeny bit, and they do form ions when they dissolve, but the reactions go much less than 100%. So we're going to classify these as non-electrolytes. If an insoluble dissolves, it's such a small amount that we simply don't get enough ions formed to have conductivity. All right. Now, you'll notice this distinction. If we just say water, we mean pure water. Tap water means we're getting it out of the tap, and it will often conduct electricity, whereas distilled water doesn't. Well, remember, there were two things we needed. We needed the water to have it to be aqueous, but we also needed ions. Since both of these have the water, it must be the ion portion of an electrolyte solution that is present in tap water. So tap water must have dissolved ions in it, and indeed it does have dissolved ions in it. And some tap water has enough to conduct weakly, and some tap water doesn't. So it really depends on the city water. So, but when it conducts electricity, it is due to the ions in tap water that are not present in distilled water. And in fact, often distilled water is also deionized. So if you look at the column and the carboy in the back of my room, that big carboy is full of deionized water. The ions have been taken out, and the water does not conduct electricity. Okay, let's take a look at a few of these to see if they conduct. We have ammonium carbonate, not you've got to know the difference between ammonium and ammonia. So carbonate's -2, so we need 2 of those. It is ionic. It is soluble. So I have a soluble ionic. When it's in water, it's going to be a strong electrolyte. Copper 2 sulfite, CuSO3. It is ionic, so it meets that criterion, but it is not soluble in water, so it's a non-electrolyte. So we need a yes, we need ionic and yes, or acid and yes in these columns. So hydrochloric acid, hydroic, came from ide, so that's HCl. It's a strong acid. Okay, is soluble. Acids by definition are in water, and it's a strong electrolyte. Acetic acid, HC2H3O2, is an acid, but it's a weak acid. It's not one of your strong ones that you memorize. It's a weak acid. It is very soluble in water, but because it's a weak acid and dissociates less than 100%, so this dissociates less than 100%, then we call that a weak electrolyte. Methane is CH4. It is covalent. It is not soluble. It is not an electrolyte. Ammonia is NH3. Ammonia is actually a weak base. As a weak base, yes, it does dissolve in water, but it will be a weak electrolyte. Okay, so hopefully you've got a foundation to begin to classify these for yourself, and we will be looking at these in a little bit more detail when we rejoin in class. So until then, as always, this is signing off. Love you, kiddos.